It's time for part 3 of the Open Source Yacht. In episode 1, we built internet, which allows for 3 different failover connections: cellular, WAN like Starlink, and a Marina Wi-Fi repeater. In part 2, we built our Raspberry Pi, we put it in a box, and on the Raspberry Pi we put an NMEA 2000 hat, and we also put a UPS backup battery supply that would safely shut down the Pi. Today, we're going to connect it all up, we're going to build out our network. So to keep things straight, I'm going to tag this stuff mostly for you guys. This is a multi-month project. Again, the intent is to get this onto a future yacht that I'm looking to purchase. So let's tag some things up. There's going to be a lot on this board when we're done. So step 1 is a powered USB hub. Deliberately bought 12 volts. I'm trying to buy 12 volts on anything that I put on this wall with the idea that it's being powered by DC boat power, all running off of a fused terminal block, which is already right here. You know, so anything that's ultimately going to get to the Pi is coming off of this. Alright, so now we can send our USB power USB in on the Pi, comes to the hub. So anything I want to connect and transmit data to the Raspberry Pi is going to come through the hub. Alright, NMEA 2000. Let me talk about this for a little bit. I think I mentioned I've had this set up in a different configuration before, and you've heard me talk before about getting what you pay for. Do not buy cheap Chinese NMEA components. I did it twice, and I spent 3 weeks trying to figure out why my network wasn't working. Ultimately, why it wasn't working is the terminators were not actually terminated. And so if you don't know about NMEA, this is not going to be the end-all explanation of NMEA, but a NMEA network has to have 2 termination points, terminators on the end. So we're going to create a fairly simple network, but regardless, they create resistance. And if the resistance is not created, the network's not closed, it's not going to work. So I bought terminators off of Amazon that were relatively cheap, especially compared to the name brand, and they simply didn't work. But as soon as I bought name brand and put it on there, everything worked perfectly. But I spent weeks troubleshooting why this wasn't working without ever thinking that the brand new components I bought were failing. The NMEA network has to be powered, so we're going to plug this into, I believe, a 5-amp fuse. I'll verify that, and I would absolutely verify that before we actually plug this into a boat. It's not going to be higher than that, but it could be a little bit lower. But for the, I'll come back and verify that we have the right amperage. All right, we're going to connect the USB hub up. Got a power light. All right, let's connect NMEA up. I would be using heat shrink connectors. Obviously, there's nothing permanent about this network. Alright, now we're going to hook NMEA into the Pi, which is here. So we're going to put this on the NMEA network. There's nothing on the NMEA network except for power right now. Alright, so curious. I wanted to test. The SunFounder PiPower board wants USB-C on its board to charge the battery. So right now, everything's unplugged, and the only way that the Pi is getting power is through the NMEA 2000 network, which is great. Pi's on, but the PiPower is not charging. So I'm going to leave this plugged in for now. We'll troubleshoot that later. Not a problem. I mean, it's got 2 power sources. It's not like I'm giving it double the power. It knows to switch between. But in the setup I was imagining, I'm only sending power to the Pi through the NMEA network. Maybe this is a good thing to have it doubled up. And I'm going to put in a den rail just to hold things on a rail system without having to individually mount them. And then lastly, an industrial gigabit Ethernet switch. Again, not expensive on Amazon. The reason why I'm using these is they are built for harsher environments. They are built for variable volt from 12 to 48 volt DC. You can actually bring 2 connections in for power, 1 for a backup, but we're just going to connect 1 for now. So in one of the negatives, we'll bring in a black And in one of the positives, we'll bring in a red. And we'll mount our label up. Temporary cables. Bring these wires over. Of course, would and will have wire ends. Powering up. The Pi would go on point 1. The uplink would go to the LAN connection on our internet. Alright, so to review, internet outputs a LAN connection for the local area network, comes into the uplink port on the gigabit switch, and our first Ethernet device is the Pi, which is our only Ethernet device right now. Then we also have basically a USB hub. We have power. Let's clean some of this wiring up, make it look a little bit better. Let's put some accessories in. First is an AIS receiver. Does not transmit, just receives. We'll work on transmit later. It's a Daisy 2 Plus, and it will be AIS antenna to the USB hub, which is how it connects into the Pi. AIS antenna is mounted over here. Just a note, it's probably not going to work inside because you got to get some height on it, but we'll give it a shot. We can mount it outside later if we need to. Power lights there. So this is called a CX5003, and if you look at the annotations, it's a dual engine monitor that has tank level monitors, fuel tank, rudder indicator, coolant temp, oil pressure, tilt trend, tachometer. Again, pick this up for steal on eBay. I mean, I'm suspicious of the cheap price. So we're going to test it as well. It is NMEA 2000. And this is an ESP32 bundle I bought from Hat Labs, a company in Europe. That develops for NMEA and Raspberry Pi. This one requires a little programming, not fully programmed, but it will let me pick up my one-wire sensors like temperature and those things pretty easily. Let's get it mounted. We're going to mount this one into the NMEA network. This one is booting. It's already set up to have a temperature unit in it. It doesn't have one connected right now, but you can obviously tell we're getting data moving and power, at least, from the NMEA network. We'll connect a bit more here. We built a little temporary mount for a GPS antenna. This is a GPS19X made by Garmin from eBay. I got used for like 19 bucks. NMEA 2000 compatible. That plugged in to our NMEA network. I know I'm going to have at least one more device on here, so I'm going to go ahead and take one of the terminators off. So right now, this network should not be functional because the terminator is off. I'm going to put another T on there, except the T doesn't fit. So as a point of illustrating how the network works, sorry, the T fits. It's just the alignment would send it backwards. So let's pretend we're sending a network down, maybe to the engine compartment or something. So we send a backbone, a thick backbone cable down, and then we start a new network down below, but we've got a T down there. And so need a couple more NMEA cables, but we'll get those. So now we have GPS on the system. We're going to connect up a block for our one-wire sensors. So this ESP32 will allow one-wire sensors to come off these three pins right here, and you connect them in series. You can connect as many as you want, and the programming, you just program them in order. So whatever you want to be temperature sensor 1, coolant sensor 2, you just put them in that order. So to make that easy, we're going to put a terminal block up that'll allow us to bring the three in, and then we'll put 1, 2, 3, 4. We can go as many as we want. It's just the programming, and we'll put them all in there. All right, so to do this, we're going to use these little pin connectors. I don't actually know what they're called. We got to get about 2 feet on them, and so we're going to solder some additional length on there. So there's one. According to the information from the manufacturer, Hat Labs, it goes yellow, red, and then black. Yellow, red, and black. Now we can wire those up. We would have a through box connection on this too. So let's keep it in the order we did down there. Temporary NMEA cable on this. I'm going to get something much shorter. Power coming on. And now I'm going to put my first one-wire sensor in. So I'm going to take one of these blocks off. So I learned that a one-wire sensor does not actually mean one wire. You've got a positive, negative, and then your one wire. And so this is a temp sensor. Let's just wire this into this block and see if we get a reading. I haven't custom programmed anything here. Yellow, red, black. Matches yellow, red, black. I'm going to put that in. We got a reading. So I'm going to put this temp sensor in my hand and hold it. And we're going to see if the temperature moves. And you may not be able to see it on screen, but it's moving. 87, 88, 89. Now I'm going to let go of it, and it starts dropping. So what would you use this for? You could strap it to almost anything. My thought is, like, exhaust. Exhaust temp is a great way to measure if something's happening to your engine. So putting extra sensors, like just strap it with a hose clamp to an exhaust pipe, pick up what the normal temperature would be, and then put a threshold so when you trip it, you know something's wrong. So let's put this on the board. I have a monitor that I bought with my Pi. I mean, I don't know that I would use a monitor because I would have a headless setup where I can VNC into it, but I got it. So let's put it on the board just to be able to monitor the Pi. All right, we're gonna just put it on the board with a little bit of Velcro. Put a couple of staples in there to keep it from pulling back. Okay, we connect on the Pi with mini HDMI. Okay, got that. And then USB. Alright, I'm gonna reboot the Pi by pulling the power from NMEA. Let's see if we now get a signal. Look at that, it is booting up. So Pi's been off for quite a while. Yeah, all of my prior configurations are good. We're gonna go over what all this means. Open CPN booted. Signal K is running. All this is gonna mean something in our next video. Got a couple spare NMEA cables that I ordered. All right, let's get a couple more appropriately sized cables on here. Checking my signal K data, and we are getting a number of things over the CAN bus. CAN 0 is the NMEA network, so that's good. We're gonna need it. And we're gonna do one more connection into our 12-volt terminal block, which is going to be for our CX5300. All right, we are going to wire up the CX5003. It needs ground and anything between 9 and 32 volts. So of course we're going to give it 12. Let's just loosely measure it over to our block. All right, slide behind this and stay in line with our other 12 volt. 12 in, ground in. Everything is powered. So there's one more thing I'm going to put up here, which is a rudder indicator. Literally, starboard port. You would attach this to your steering drive. Just going to mount it right now. We'll do the configuration when we get to the software portion of this. It is a one wire as well, and it goes to, honestly, I think either one of the rudders, but let's put it on the starboard rudder and we're gonna see how it receives. These are pre-configured NMEA connections, so it's gonna send in the PGM code. 1, 2, 3, 4, 5. So that's rudder. If I remember correctly, because I played with this before, the other side of it has to be grounded. But we'll deal with that later. All right, so that is it for the network and devices. We'll probably add some more devices along the way, but that's the major network. So in part 4, we're gonna go over the software. We're gonna bring it all together, we're gonna use it, and we're going to start to conclude this series on can we build an open source yacht, probably for about $500 bucks. That's where I am on this investment right now. Stay tuned.